Hi everybody and welcome to our Saturday sessions today with ExamRevision. I'm going to be taking you through the Leaving Cert Maths course, and today we're going to be focusing on a paper 2 topic, which is trigonometry. So to start off with, I just want to chat to you really quickly about our Easter revision courses. We've got a few questions coming in this week since our YouTube live last week. So just to say, the easiest way to book the Easter revision courses, instead of maybe contacting us through Facebook or Instagram asking to sign up, the easiest thing to do is to log on to our website. And if you go into book Easter revision courses, and you'll see all of the details then about our revision courses. So again, all our outstanding teachers, it's going to be online and on demand, so you will be able to view it live with the teacher and ask questions over Zoom, but you'll also be able to watch the recording of the revision 4 or 5 hour courses anytime you want from now up until your Leaving Cert exams. And obviously we have our H1 notes provided to all students as well. So just again a reminder that if you would like to avail of our deal for $79.99, that you've got another 7 days to do that, and you need to book before the 20th of March. Now, one of the kind of main areas that people have been contacting us about in the last day or two is in relation to our French and and Irish oral preparation. So if you do click into the course info here, it will take you through exactly what's involved on both of those, and obviously all of the different courses that we have available. But I suppose a lot of Leaving Cert students are thinking about their French or your Irish oral exams at the moment, because they are coming up quite soon. So I suppose the main thing to take from those two in particular is that they are both being delivered by teachers who have experience being state examiners and doing the oral exams. And I suppose what we've asked the two teachers delivering the courses to really focus on is how to get you guys as prepared as possible, and also help you to learn tips of how to actually structure your own oral exam, and that when you're in the exam, it's really brilliant if you can allow the examiner to kind of start asking you questions that you want to be asked, rather than maybe going down topics that you haven't prepared. So that's definitely going to be one of the main focuses of the oral prep that we have coming up on the 27th and the 28th of March. And then if you look down further, then you'll see all of the other exams subjects that we have available over the 2 weeks of Easter. And if you do have any siblings or friends that are junior cycle students, we also are offering some junior cycle courses. And again, they're actually very popular at the moment, with students trying to catch up on maybe areas that they might have missed with all the online learning over the last 2 years. And definitely, I suppose, again, with our higher level and our ordinary level revision courses for the Leaving Cert, we're going to be trying to get you guys as updated as possible on what's coming up on all the different exams. We're due another update from the department in the next week. So hopefully we'll be able to then deliver even more of an in-depth structure with the exam, so that you guys are able to really apply the new learning from these updates from the department to your revision, and it will really give you the chance to maximize how you're spending your time. And what we really do pride ourselves here at ExamRevision is that we're getting you ready for the exam. We're giving you all the tips and the tricks that you need to know, and it will in the end will save you time on your revision as well. So again, if there's any other questions, feel free to message us on Instagram in relation to those revision courses. But if you would like to book them, the easiest way is just to come straight onto our website instead of trying to do it over that platform. So we're going to get back into our maths then. So if there is any other questions, feel free to let us know. And then just another update about our Saturday sessions. We have lots coming up over the next few weeks. So any Leaving Cert Chemistry students, we have our Saturday session on Leaving Cert Chemistry taking place next Saturday, and we're going to be focusing on water in that one. The following week, we've got a Leaving Cert Geography Saturday session, and that's going to be focusing on regional geography. And then going on from that, we've got a few junior cycle, and then we're into Leaving Cert Economics and English. So again, if there is any particular topics that you'd like help with, or any particular areas, do feel free to get in contact with us on Instagram. Is definitely the easiest kind of place to do that. Okay, so we're going to get into our trigonometry then for today's Saturday session. So as I said, guys, the whole course is broken down in both our Easter revision courses and our website. So this gives you the breakdown from a paper perspective, so you can see your paper 1 topics, your paper 2 topics. So we're going to be focusing on trigonometry today, which is on paper 2 of the Leaving Cert Ordinary Level and Higher Level exam. And again, I know anyone who's tuned into our Saturday sessions previously, and any of the midterm revisions I did, will have seen this many times, but I think it's always brilliant to bring it up just again to emphasize the importance of the different topics that we're going through each week. And the reason why I decided to do trigonometry in today's Saturday session was because you can see again in the green how regular it does come up on the exam. So you can see it's coming up there 3 or 4 times every year over the last 6 years. So it's definitely a topic that I would recommend that you spend time going back over. And obviously I'm going to take you through for the next hour as much of the trigonometry course as I can, but the entire trigonometry course is broken down into videos and our notes on our website as well. So do make sure to check that out. So this is our revision list for trigonometry. So when you're starting your revision and when you're kind of getting into looking at specifics within the trigonometry chapter, this would be your kind of revision list or your checklist as you're going along. So again, you will recognize some of those terms from your junior cert as well. So you would have done Pythagoras' theorem, and you would have looked at your sine, cos and tan as well in your junior certs. So that's definitely something that should be, I suppose, more of a recap than anything new. And again, you can see I've marked with HL for our higher level students. The ones there that are marked with HL are the ones that you would need to know, whereas ordinary level students, you guys need to know the ones that don't have HL beside them. So we're going to get straight into it then, and we're going to start off with the most obvious place, which is Pythagoras' theorem and our trig ratios. So the first thing is just a reminder that your Pythagoras' theorem and your sine, cos and tan trig ratios are all found on page 16 of your formula tables. Now, in your junior cycle in particular, you may or may not have ever looked at this page because you probably just knew all these off by heart. You would have probably remembered in junior cert, you would have been thinking about your SOHCAHTOA potentially to help you remember all of the different things to do with your trig ratios. And I suppose sometimes when I go to teach this to students in, let's say, first or second year, I don't like showing them this in their formula tables because they see A and C and B and C and A and B, and they're not quite sure how does that link with the actual trig ratios. So it's just a reminder again, when you're drawing your right angle triangles, and we have here angle A, that we always start by labeling the hypotenuse. So the hypotenuse is always opposite the right angle, so we label that H. We label the side opposite the angle that we're kind of dealing with as O, and we label the other side A for the adjacent. So when you look in your formula tables on page 16, you will see A over C, but A is obviously your opposite and C is your hypotenuse. So that's where we get O over H. Your cos A then is going to be equals to A over H, and your tan is going to be O over A. Okay, so again, you don't necessarily need to learn those off by heart, but it is something that you do need to be able to understand from page 16, what side is the hypotenuse, what side is the opposite, and what side is your adjacent. And then Pythagoras' theorem is definitely one that a lot of students would just know off by heart, but it is there for you as well on page 16. So we're going to get straight into looking at a question now. This question is taken from the ordinary level Leaving Cert, but again, as I've said many weeks before, this is something that Leaving Cert higher level students would also be expected to be able to answer, but I am trying to, I suppose, have a mix of higher level and ordinary level questions, and this is a great question. So let's have a look at this to begin. So we're being given a right angle triangle. Now, I'm going to talk to you in more detail in a few minutes about the extra things that we need to know from a leaving cert perspective. But even at this stage, you're looking at this question and straight away in your head, you need to remember, okay, this is a right angle triangle. So I'm going to use the rules that I've known since I was in first or second year of secondary school. And that's that I can use Pythagoras' theorem, or I can use my sine, cos, or tan trig ratios. So to start off with, let's read through it. So we're told that we have this right angle triangle and that we're first of all being asked to find the value of x. Now, sometimes when we are looking at trigonometry as an entire topic, you may kind of look at it and think, am I supposed to use sine, cos, or tan here, or am I supposed to use Pythagoras' theorem? So the easiest way to remember it is Pythagoras' theorem will only work with sides of your right angle triangle. So it's not going to work with angles. We don't care about the angles. Obviously, we need the right angle, but after that, Pythagoras' theorem only deals with the sides. So in this particular first part of this question, we can see we have two of the sides and we're being asked to work out the third one. So Pythagoras' theorem would be the logical one to use here. So again, I'm not going to go through this in loads of detail because I want to get on to the more challenging material. But again, we just know that in Pythagoras' theorem, we have the hypotenuse squared is equals to the two shorter sides squared added together. So it's going to be set up like this. And again, you bring the 17 squared and the minus 15 squared, pop that into your calculator, and then you find the square root of it. And the answer that we get for that one is x is equals to 8. So again, for all these questions, what we're looking at is applying a formula and then executing it and make sure we're showing our working as well. For the second one, we are asked to write down as a fraction the value of sine theta. Now, what's really important in this one is they're asking us to write down what sine theta is. They're not asking us for theta. Okay, they actually just want us to write down what sine theta is. So what we need to remember is we are dealing with sine, cos, and tan. So I always like to just write that down straight away. So, ka, toa. And it reminds me what sides of my right angle triangle go with my trig ratio. So I know for sine, I'm dealing with so. So that means that sine theta is equals to O over H. So therefore, to get what sine theta is equals to, we need to go over to our right angle triangle and we need to label it. So again, we always start by labeling our right angle, the side opposite our right angle, so that's going to be H. We then go and label the side opposite our angle, which is O, and we then label the side underneath, which is A, okay, or the leftover side. So O is equals to 15 and H is equals to 17. So we have that sine theta is equals to 15 over 17, and that simply is our answer. We don't have to do anything else. I know instinctively you would think we have to go and get rid of the sine and do sine inverse to both sides, but we don't need to. We're just being asked for sine theta. So moving on then, we're going to calculate what cos theta is. Okay, and we're going to do the same thing. Okay, so sorry, I've just realised I wrote that slightly outside, so I'll just write that under here. So toa. So for this one, we want to work out what cos is equals to. So that's your ka. So that means that cos theta is going to be equals to A over H. So therefore, cos theta is equals to x over 17. But what we need to remember is that we've just worked out what x is equals to. So cos theta is equals to 8 over 17 because we worked out that our missing side from part 1 was equals to 8. Okay, and for the next part of our question, it would be really useful if we had our formula tables. So I'd suggest for everyone to get their formula tables out so that we can have a discussion around the next question. So we're being asked to find the value of sine 2 theta. Okay, so I suppose the first thing that you're going to need to think about here is that we're not used to looking from, let's say, even our junior cert, we're not used to there being a number in front of our angle. So that's always a good sign where you're thinking, okay, this is maybe something new and I might need to use my formula tables for this. So the first thing that you're going to do is you're going to open up your formula tables, and I'd always say kind of look at around page 13, page 14 or page 15. So if we go, and a lot of you are probably familiar with this, but if we go to page 14, we know we have some formula there that might help us. And we want to look in particular at the double angle formulae. So it's kind of the second half of page 14. And if you look to the left-hand side, the second one down in your double angle formulae section, you'll see that there's a formula there that says sine 2a is equals to 2 sine a cos a. And that's the formula that we're going to use, because what we can see here is, okay, I'm not quite sure how to work out sine 2 theta. But if I use this formula, let's have a look and see what we actually need. We just need sine A and cos A, or in this case, it's going to be sine theta and cos theta. And if we look to the previous parts of our question, we've already written down a fraction to represent sine theta, and we've already written down a fraction to represent cos theta. So basically, we've done all the hard work already. So therefore, sine 2 theta is going to be equals to 2 bracket sine theta, which in this case is 15 over 17, multiplied by cos theta, which is 8 over 17. So therefore, sine 2 theta, we're going to pop all that into our calculators, and we get an answer of 240 over 289. Okay, and they didn't ask us to round it to any particular decimal place, so that's why I would always suggest leaving it as a fraction, because it keeps it in its purest form and you don't have to go and round it. And again, just to highlight, they didn't ask us to work out what theta was, they asked us to represent sine 2 theta, and that is your answer there. Okay, so as I said, that's taken from the ordinary level Leaving Cert, but it does build on some good kind of work that you would all be expected to be able to answer. Okay, moving on then, we have another quick recap question just to get us thinking. Again, this is taken from the ordinary level Leaving Cert. So we have a vertical mass, and it's called PQ, and it's supported by 2 straight cables, PS and PR, as shown. The cables are joined to level ground at S and R, and we're told that the distance between S or is 15, and that's marked down for us. The distance between RQ is 17.4, and the angle P or Q is equals to 50. Now, just a quick recap, whenever you're reading angles, you start at the outside one, or the point, you go down, you go down to the middle one, and you go out like that. So that's how we know that that one's 50. Now look, obviously in this exam question, it was already marked in for us. Sometimes it won't be. So always read through and make sure all of those things are marked into your diagram. So first things first, we're being asked to work out the distance P or. Okay, so again, those 2 lines mean the distance between P to R. So we're dealing with this distance here. Okay, so what I would always recommend is you kind of have 2 triangles going on here. So to kind of make this easier to work with, draw out one of the triangles that we're dealing with. So I know that's 50, and I know this is 17.4, and I know they're trying to work this out. So X, so I can label that. So this is again just a very quick recap of junior cert trigonometry. So you're going to start off by labeling it H, O, and A. And what I always say to my students is circle what you know and circle what you're trying to work out. So I know that the adjacent is 17.4, and I know I've got 50 degrees, and I'm trying to work out what H is, which is X. So then you look and see what are the 2 red letters that I have circled. I have A and H. So again, we think of so, ka, toa. And we say to ourselves, okay, which one has A and H in it? And it's ka. So that means it's going to be cos. And we always put the angle with cos, sine, cos, or tan. So it's going to be cos 50 is equals to A, which is 17.4, over H, which in this case is X. Okay, so what's going to happen then is we want to get X by itself. So we're going to multiply to get X up here, and then we're then going to have to divide to get X by itself. So basically these end up kind of swapping places. Now I don't like teaching it like that, but that's kind of what happens. So again, you're multiplying both sides by X, and then you're dividing both sides by cos 50. And you're going to pop that into your calculator. So 17.4 divided by cos 50, and we're being asked to round it to the nearest meter. So we get 27 meters. Okay, so I now know that that's 27 meters. So that's part one. Then part two of our question is asking us to work out the distance from P to S. So we're being asked to work out this distance here. Okay, now there's two ways of answering the next question. We're going to answer it first of all using, let's say, junior cert trigonometry. So we're just going to look at it and say, okay, I don't know that much about it. I'm going to try and see, is there any way of making this into one kind of large triangle? So if I take this section here, so let's label this Y, and I know that if I'm thinking about this as one big triangle, okay, what we're looking at here is we're thinking, okay, I know that this distance here down the bottom is 15 points plus 17.4 meters. So if I could only work out this side, well then I'd be able to use Pythagoras' theorem and I'd be able to get my answer. So let's go back into that smaller triangle for a second and think to ourselves, well, can I work out this side here? And hopefully you can see we can. Now we've got a few different options. What I would say is, so if I'm just going to redraw this out here for a second. So I'm redrawing out the smaller triangle. Just kind of think about what you know from this triangle already. Like, what have you been given in your exam question? We've been given the 50 degrees, we've been given the 17.4, and I'm trying to work this side out here. Now, I know we know the other side is 27, so you could think about using Pythagoras' theorem. One thing that I would always kind of say to my students, though, is kind of just a recommendation, is if you can work out an answer without using an answer that you've already kind of calculated within a question, it can sometimes be more beneficial, because if you had made a mistake in the first part, you won't necessarily be impacted in the second part of the question. So again, this is just a quick recap of trigonometry using your sine, cos and tan. So we're going to label this. So we've got H, O and A, and this time I want to use my adjacent. I want to work out the opposite, and I know my 50, so it's going to be tan. So I'm going to say tan 50 is equals to O over A, which is 17.4. So to get O, then I multiply both sides by 17.4. So the opposite is going to be equals to 20.7365 ... Okay, so now I know what that side is. So I can actually just draw a little arrow there. So I now know that that side is 20.7, let's say. And I know I've got this distance here. So therefore I can use Pythagoras' theorem, and I can say y squared is equals to 20.7365 squared plus 15 plus 17.4 squared. And therefore y is equals to 38 meters. Again, we're rounding that to the nearest meter. Okay, so you pop that into your calculator, you square root it, and we get y is equals to 38. Now, that's your final answer there. You're done and dusted. However, what I want to introduce next is the idea that we could have done that question a little bit differently if we had have just focused on this triangle here. Okay, so if I had just focused on the green bit of this triangle, we could have answered this question differently, and we're going to talk about it now in a few minutes. We would have had your 15 meters here. We would have had your 27 meters here, and I would have been able to work out this angle because it's a straight line, so that would have been 130 degrees. Okay, and we would then have been able to go and calculate this side here. However, what we're beginning to see in this particular question is that you don't, sorry, I know I'm after drawing that slightly outside again, we don't actually have all of that information available to us until we go and do the Leaving Cert course, because up until this point, we've only been able to deal with right angle triangles. So what we need to start thinking now is, okay, well, I've got a triangle that's not a right angle triangle. So how is this going to work? And that's where we start bringing in our sine rule and our cosine rule. Okay, so again, we're going to come back to that question in a second once we have a quick chat about that. Okay, so if I show you this, so this is where we start thinking, okay, stuff on the left is all the things we did in our junior cycle. The stuff on the right is kind of the new Leaving Cert stuff. So when we're dealing with triangles in the exam, the first question you're going to say to yourself is, are we talking about a right angle triangle or are we talking about a non-right angle triangle? If we're talking about a right angle triangle, you're going to keep going with all your junior cycle knowledge. You're going to think about Pythagoras' theorem and your SOHCAHTOA or your sine, cos, or tan. If it's a non-right angle triangle, you're going to think to yourself, okay, I've got two options. I've got my sine rule and I've got my cosine rule. And we're going to discuss those now in a little bit more detail and kind of figure out when we use each one. So again, your formula table is really useful here. It's going to give you the breakdown of your sine rule and your cosine rule. So if you go to page 16, this can be found at the top of page 16. So we've got our sine rule and we've got our cosine rule, and we'll come back to the area formula there later on. So what I would say to you is, what I would always recommend is that you start with seeing, does the sine rule work? And if the sine rule doesn't work, then you can see, and hopefully it should, the cosine rule will come in and work for you. Now, again, you're thinking about, well, how do I know which one is going to work? So the trick is, with the sine rule, you're always looking for two matching pairs. And I'll explain it to you here now with this diagram. So again, in your formula tables on page 16, you can see we've got a non-right angle triangle, and you can see all the angles have been labelled with capital letters and all the sides have been labelled with lowercase letters. And there's a connection between them. You can see that where we have big A or capital A, the side opposite it is little a. Where we have capital B, the side opposite it is lowercase b, and where we have capital C, the side opposite is lowercase c. And when we want to use the sine rule, basically what we're going to be checking for is, do I have an angle and a side that are matching up? So I need one of them to match up that way, and then I need another one, either B or C, to match up. And if you can draw on two arrows, you should be able to use your sine rule. And one of those can be the unknown, okay? So obviously the unknown is the thing we're trying to work out. But if you can draw on two arrows where you've got a matching angle on a matching side, one of them is allowed to be the unknown, you can use your sine rule. If you don't have two matching pairs, that's where the cosine rule comes in. Take you back to this question that we were looking at a minute ago. And if we look here, I'm actually going to just slightly improve this drawing I did. So if we look at the green triangle, and we think about the fact that yes, we knew that was 15, we had worked out that was 27, and we said that we could work this out by doing 180 minus 50, which gives you 130 degrees. Okay, and this is a non-right angle triangle. So straight away you're thinking the sine rule or the cosine rule. So we said to use the sine rule, what you're going to do is see, can you draw two arrows where you've got matching sides? Okay, now I'm going to label the unknown side. Remember, we're trying to work out PS, which is this along here. So let's label this side say Z. Okay, so I'm trying to work out Z. So I can see the 130 is matching with my Z. So that's one matching pair. But the issue I have is my 15 doesn't have a matching angle, or my 27 doesn't have a matching angle. I can't draw another arrow there. So that means the sine rule is not going to work. So therefore, I'm going to try and use my cosine rule. Okay, so the first thing you're going to do for your cosine rule is obviously go to page 16 and write down the formula. Okay, so again, that's kind of the middle part of page 16. Now I'm just going to make some room for myself here. So I'm going to start off by writing down my cosine rule formula. So that says that a squared is equals to b squared plus c squared minus 2bc cos a. Okay, so just to explain to you then where all of the a, b's and c's and things come from. It doesn't really matter exactly how you label your non-right angle triangle, but there's one really important thing for your cosine rule. And that's that whatever is the side or the angle that you're trying to work out, it should be represented with either capital A or lowercase a, depending if it's a side or if it's an angle. So in this particular example, we know we've got z there. That's our unknown side. So we're going to label that little a. And therefore, that means that 130 degrees has to be the capital A. Now, the 15 and the 27 meters, it doesn't matter which one they are, B or C or B the other way around, but it's really important that the missing side or the missing angle is always labelled as lowercase a or capital A. So we're going to go and fill this in now. So it's saying a squared, so that's z squared is equals to b squared, which is going to be 15, plus c squared, which is 27, minus 2 times b, which is 15, times c, which is 27, times by cos of a, which we know is 130. So you're going to go and literally put the entire right hand side into your calculator, and you're then going to find the square root of it, and the answer that you get is, again, rounded to the nearest meter, is 38 meters. And again, that was the same answer that we got earlier when we worked out using our right angle triangles to work out that answer. Okay, so that is your an example of your cosine rule. We're going to go and have a look at another question here. So again, this is our last kind of ordinary level question we're going to be talking about today. So this is again taken from the ordinary level Leaving Cert papers, but again, very much relevant to the higher level curriculum as well. So in this question, we have two different triangles, and you can see very quickly we're being asked to work out the value of x and the value of y. So straight away, whether this was on a higher level or an ordinary level paper, you need to look at this question and say to yourself, okay, these are triangles. So step one, I need to say to myself, is it a right angle triangle or is it a non-right angle triangle? And I can see they are both non-right angle triangles. So next we're thinking, okay, that means we need to use our sine rule or our cosine rule. So I always start off trying to see, will my sine rule work? So remember, I'm trying to find matching pairs between opposite sides and angles. So straight away I can see one here, my 10 centimeters is linking up with my 63 degrees. And then I'm thinking, oh no, the x doesn't have anything opposite it. However, what you should notice is that we actually have 2 out of the 3 angles there in my right angle, or my non-right angle triangle, I should say. And we know that in a triangle, the angles add up to 180. So very quickly, I can actually work out that that's 52 degrees. So I actually do have 2 matching pairs. So therefore, I'm going to use my sine rule. Now again, go to page 16 and have a look at your sine rule. One important thing to note, which some of you may remember being told in your classes, is that the sine rule can be used to work out missing sides or missing angles. So in this particular question, we're being asked to work out a missing side. So we're going to keep the formula exactly as it is on page 16. But just a little note, and I do go through this in a lot more detail on the video on the sine rule on our website, but if you're trying to work out a missing angle, one trick you can use, you don't have to, but you can flip all those fractions upside down. And it just means that the unknown is then at the top of your fraction. You don't have to do it. It's just something that you may remember your teacher talking to you about. We won't need to do it in this question because our unknown is the missing side. So x is going to be on the top of our fraction. Okay, so the way it works is, in our formula tables, we're told that a over sine A is equals to b over sine B is equals to c over sine C. Now, the great thing is we don't need all three of those fractions. We're just going to use two of them. So we're going to start off always with our unknown. So I'm going to say x over, and I need to match it with its matching angle. So it's going to be sine 52 is equals to, so again, I'm going back to a side here because it's lowercase. So I'm going to have 10 over its matching angle, which is sine 63. So again, sine should always be joined by an angle. And what you're going to do then to get your final answer is you're going to multiply both sides by sine 52. So it's going to end up being 10 sine 52 over sine 63. You're going to pop that into your calculator and you get an answer that x is equals to 8.84 centimeters. Again, just take note of the fact that we're being asked to round it to two decimal places. Okay, next question. We're going to try and see, can we use our sine rule again? So again, I can see that the 53.8 matches with my y, but I don't have another matching side and or angle, and there's no way I can work it out. So we're going to try our cosine rule. And again, the one thing you need to remember about your cosine rule is that we have a matching, or the side that we're trying to work out has a matching angle, and we're going to have to label that angle as capital A, and therefore this side is lowercase a. The other two sides, it doesn't really matter which order you do, but they're going to be B and C. Now, we've already done an example like this in the previous one, so I'll just write this down quickly. So it's going to be y squared is equals to, so it's b squared plus c squared, so it's going to be 8.5 squared plus 10.2 squared minus 2bc, so 8.5, 10.2 cos of a, which is 53.8. So you go and put the entire right hand side into your calculator and then square root it, and we get an answer that y is equals to 8.60 centimeters. Again, we're being asked to round to two decimal places. That's why I have got my 0 written down there as well. So again, that's how we do our sine rule and our cosine rule. Okay, now this next question is actually taken from the higher level curriculum. I'm not going to do it now because we've done a lot of practice on the cosine rule, but it's just to show you that it does come up quite simply on the higher level course too. So that was taken from a higher level question. But again, I've left the mark scheme in there, guys. It's simply just applying your cosine rule so you can have a look back over that in your own time. Okay, the next thing I want to talk to you about then is the area of a triangle. So when we looked at page 16, I mentioned that there was another formula there, which is half AB sine C. So this is just a reminder that yes, we know from primary school that if we're ever asked to work out the area of a triangle, we know we have half the base by the perpendicular height. That still will work, but this is just another formula that you can use, and it's particularly useful when we don't know the perpendicular height and when we have a non-right angle triangle. So again, it's just using the same labeling as we discussed already, and we're saying half AB sine C. And we'll look at that in relation to a question now in a second. So if we have a look here at this question. So I'm just going to make this a little bit smaller. Okay, so we're told the diagram below shows a triangular patch of ground. Okay, and we're told that the distance from S to H is 58 and the distance from G to H is 30. And the angle GHS, so again, think about it as from going from G to H to S, is 68 degrees. So the first thing we're being asked to do is to find SG. So that's the distance from S to G. So you're going to be looking at the fact that we have a non-right angle triangle there. Forget about the circle for the moment. So we've got a non-right angle triangle, so we're thinking sine rule, cosine rule. Very quickly, you're probably seeing how these kind of happen. You can see, okay, yeah, this is the side I'm trying to work out. Let's label it X. They are a matching side, but I don't have any other matching sides. So I'm going to have to use the cosine rule. Again, I'm going to skip through this part quite quickly because I want to get on to the rest of this question. Again, this is a higher level question. So it's going to be x squared is equals 2. So I should be writing out my formula here, okay? So I'm being a little bit lazy, but I just want to get on to the next section as quickly as I can. So it's going to be a squared is equals to b squared plus c squared minus 2bc cos A, which is 68. So again, pop that into your calculator, find the square root, and we get an answer 54.4 meters. Remember, I was asked to round it to the nearest, to one decimal place. So 54.4 meters. Next part, we're being asked to work out the angle HSG. So again, look at your diagram and go to H, then go to S, then go to G. So we can see it's this angle in here. So I'm being asked to work out that angle. So what we're going to do then is think again, right, it's a non-right angle triangle, sine rule, cosine rule. So let's just try the sine rule to see will that work. So if I call this one A, so I can see I've got that matching pair. And I also now have a matching pair because I've worked out that opposite side to be 54.4. So we can use the sine rule. Now this one is a good example to show you where we're going to flip the sine rule fraction upside down because I'm finding a missing angle. Now you don't have to do this, okay? This is not something that's required, but I just thought it would be a good way to show you. Again, I know a lot of teachers do teach it this way. So we always start off with the unknown, okay? So I'm going to start off with A, but I don't just write down A because A is an angle, so I write down sine A. And I divide it by its matching or its opposite side, which is 30. And I'm letting that equals 2. So I'm going back to the angle. So it's going to be sine 68 over its matching side, which is 54.4. We want to get rid of the 30, so we multiply both sides by 30. So we end up getting 30 sine 68 over 54.4. And then we do sine inverse to both sides. So onto your calculator, you're going to have to do sine inverse and this fraction here. And the answer, and sorry, I've just realized I've written outside the screen again. But the answer you're going to get is A is equals to 30.75. 30.75 degrees. So that's our angle now that we've worked out. And then finally, we're being asked to work out the area of SGH, so the triangle SGH. So because this is a non-right angle triangle, it would be quite difficult for us to work out the perpendicular height right now. So we're going to use that new formula that we've learned about, which is half AB sine C. Now, the most important thing to remember is when you're dealing with the area of a triangle, it doesn't matter if in a previous section you've labelled one of these A, B or C. You can change them up if you're going on to a new formula. So basically what we're thinking about here is angle C is whatever angle you want it to be. So I'm going to say this one here is angle C. And therefore the two sides that I need to put into it are the sides that surround that angle. So if that's angle C, that would mean that that side there would be C. So therefore this would be A and B. That's the only little thing just to look out for on that formula. So we're going to get half A, which I'm saying is 30, by B, which is 58, by sine C, and again C is 68 degrees. Pop that all into your calculator and we get the answer 806.65, and remember it's area, so that's going to be meters squared. Okay, and that's your answer for that one. So just to show you how to apply those formulae to different exam questions. Okay, moving on then, I want to talk to you about some 3D trigonometry. So just a quick reminder about the angle of elevation and the angle of depression. Just remember that we always take it from kind of eye level. So if you're asked for the angle of depression, you draw a straight line and then it's the angle going down from that. Or if you're asked for the angle of elevation, it's a straight line and the angle going up from that. Now, this question is a 3D trigonometry question from the higher level Leaving Cert course. Okay. Now, again, what I would say to you about 3D trigonometry, I always say to my own students, is that we don't have fancy formulae for 3D trigonometry. You don't know, or you don't need to know anything new. You're going to be applying knowledge from the 2D trigonometry stuff that we know up until this point. So basically, when you're doing any of these questions, keep thinking to yourself, Pythagoras' theorem, sine, cos, and tan, the sine rule, the cosine rule, and maybe, let's say, the area of a triangle, which can be from a right angle triangle or from a non-right angle triangle. And that should really help you to kind of get to grips with these questions. So in the first part, we're being asked to show that the distance AC is equals to 1.95. Now, another little tip or thing to note from the exam papers, if you're ever asked to show that something is equals to a particular length or whatever it is, keep that in the back of your mind that they've given you that answer. So even if you can't work it out, that you now have that answer to use in later parts of this question. That's something that's really important. So even if you can't answer A part 1, keep going because you can then use that answer in other sections of the paper. So we're being asked to show that the distance AC, which is here, is 1.95. Okay, so you're looking at this to start off with and you're thinking, right, that's quite difficult because that's like a non-right angle triangle. I don't know anything about the angles right now. I don't really know that much. But what I do notice is that I know the width and the length of the rectangular shape down the bottom of my 3D shape. So I'm thinking, well, if I can work out this distance here, that's obviously going to be the same as this one here. And then I can half it. And that should give me that distance AC. So let's try that to start off with. So I'm going to work out kind of FD to begin with. So I'm saying the distance FD, and it's just a right angle triangle. So again, if you want to draw it out there, you can see you've got your 3 meters and your 2.5 meters. So I'm going to say FD squared is equals to 3 squared plus 2.5 squared. So F to D is going to be the square root of that. So that's going to be the square root of 9 plus 2.5 squared. And that is giving me the square root of 61 over 2. However, I only want half that distance, so I'm going to divide that by 2. So therefore, AC is going to be the square root of 61 divided by 2, divided by 2. And that gives me, when I press S to D, 1.95 rounded to 2 decimal places. And obviously I can see I've got that done correctly there. Okay, the next part, it says the angle of elevation of B from C. Okay, now this is really important. So they're saying of B from C. So you need to imagine you're at C, you draw a straight line down onto the ground, and we're being told that the angle of elevation upwards to B is 50 degrees. Okay, so if I was to redraw that section of that triangle, I can see that it's this bit here is 50 degrees. Okay, and I've just worked out AC, or even if I didn't, even if I couldn't do that part, I can take that answer from part 1. I know that's 1.95, and they're asking us to work out AB. Okay, now again, they're asking us to show that AB is 2.3, but basically they want us to work it out. So now I've got a nice right angle triangle question, could have been on my junior cert, so I'm going to label it H, O and A, circle what I know, what I'm trying to work out. So I've circled O and A, so that's TOA, so it's tan. So tan 50 is equals to O over A. So X is going to be equals to 1.95 tan 50. So onto my calculator, 1.95 tan 50, and that is giving me an answer of 2.3 meters. And again, that's what we were asked to show. Moving on to the next part then, we're being asked to work out the distance BC. So that one's actually quite straightforward because look at it here. Okay, we're being asked to work out this distance. So if I go back to that triangle I just drew a second ago, we know this is 1.95 and we know this is 2.3. So if I'm being asked to work out BC, I just have to use Pythagoras' theorem. Now again, the reason why you would have been able to answer that without even doing part 1 and part 2 is because they gave you both of those answers. So even if you didn't go and calculate them, you should be able to use them later on in your question. So I'm going to work out the square root of 2.5 squared plus 1.95 squared, and that gives me 3.01, but we're being asked to round it to the nearest metre, so it's 3 metres. And the last bit of this question that we're going to look at then is we're being asked to work out the angle BCD. Okay, so we're going back to this diagram, the angle BCD. So we're being asked to work out this angle. Now what you need to imagine is that this triangle that we're dealing with for the last part is like the front of my triangle. Okay, so it's the front face of my, or not my, of my triangle, of my pyramid I should say. They're asking us to work out this angle. So we need to think about what we know, or have we worked out anything in this question that can help us? So I know that's 2.5. And let's go back to what we just answered in part 3. We worked out what BC is. So that's 3 meters. Okay. And because we had a rectangle at the base here, we knew that this was all 3 meters and 2.5 meters. So that means that when they all join up, you're going to have the same length on all of your triangles. So that means that this is 3 meters as well. So therefore, we're going to be able to use one of our non-right angle triangle formulae, so either the sine rule or the cosine rule. Now the sine rule definitely isn't going to work because we have our unknown and our opposite side, but I don't have any other angles. So I'm going to have to use my cosine rule. Okay, so we're going to write down our formula. So a squared is equals to b squared plus c squared plus 2bc cos a. So again, with our cosine rule, we remember that the missing side or angle has to be labelled as A, and the other ones, it doesn't really matter. So let's go and fill this in. So it's going to be 3 squared is equals to 3 squared plus 2.5 squared minus 2 times 3 by 2.5. I'm just going to have to come down here, multiplied by cos of A. So I'm going to bring all that stuff over to the other side. Okay, I'm just going to bring my equal sign in here. So it's going to be 3 squared minus 3 squared minus 2.5 squared. And that's equals to minus 2 by 3 by 2.5 cos A. That's all stuck onto cos A at the moment. So if I want cos A by itself, I need to divide by all that stuff. So it's going to be 3 squared minus 3 squared minus 2.5 squared divided by minus 2 by 3 by 2.5. Now, look, I know I'm being a bit lazy here. I'm not actually working anything out. I'm leaving it all in its original form. Of course, you guys could go and calculate each of those bits separately if you wanted to. So we end up getting then that cos A is equals to all that. So to get A, I just have to do cos inverse of this fraction. So you're going to do cos inverse of our fraction and you're going to get an answer of 65 degrees. So I'll just write that in there. You're going to do cos inverse of your fraction. And again, guys, doing this question, I'm taking it that you have a certain level of understanding based on the chapter that we're on at the moment. But if you feel like you need to do a little bit more work on it, do check out the videos on trigonometry on our website as well. Okay, so I'm going to keep going here because I want to talk to you a little bit about radians and your graphs of sine, cos and tan. So for radians, just to explain first of all that 1 radian is the measure of the angle at the centre of a circle with the length of the arc being equal to the length of the radius. So you can see it here in my diagram that you've got this circle, it's got a radius, and then the arc length is also r as well. And that angle in here is 1 radian. So one really important thing that you need to learn off by heart, first of all, I always say this one here. I think this is important, that at 360 degrees is obviously one full resolution of a circle. So that's equals to 2 pi radians. Now, if you check out the video on exam revision, I go through why that works. I'm not going to have time to talk about it today, but that's what the first thing I think you should learn off by heart. So that 2 pi radians is 360 degrees. So if you wanted to work out for your conversions, if you wanted to work out what 1 degree is, you would simply divide both sides by 360. So you'll have 2 pi divided by 360 radians. So therefore 1 pi is equals to, goes in there 180 times, so pi over 180 radians. And you can see that's where that answer comes from. And similarly, if you wanted to get 1 radian, you divide both sides by 2 pi. So just to explain where that comes from. So you can see here I've got the conversions written down. That's kind of the quick way of doing it, I suppose. So if you were being asked to convert 120 degrees to radians, what you need to remember then is the conversions. Okay, so if I go back here, you're thinking, how do I convert degrees into radians? So basically what we're going to do is we're going to think about dividing it by 180 and adding your pi to your answer. So you're going to do 120 and you're going to multiply it by pi over 180. So you're going to do 120 multiplied by like 1 over 180 if you want to, or divide it by 180 and add on pi. So you're going to get an answer of 2 pi over 3 radians. And if you want to convert pi over 12 radians into degrees, you're going to multiply it by 180 over pi. So it's going to be pi over 12 multiplied by 180 over pi. So the pi's are going to go into each other and you're going to get 180 divided by 12, and that gives you 15 degrees. Okay, the next thing I want to talk to you about for the last kind of 5 minutes or so is our unit circle. And this is our unit circle where we have our radius is obviously 1. Okay, there's a few really quick things you need to know about your unit circle, and the most important thing is its connection with your x and your y coordinates in your unit circle. So just to explain then, and I don't have time to go into the ins and outs of it, but basically if you're trying to work out cos theta in a unit circle, it's going to be the value of your x coordinate in your unit circle. And similarly, if you want to work out sine theta, it's going to be your y value in your unit circle. Okay, so if you're coming around here, you can see you've got your different x and y coordinates that would link with cos theta and with sine theta based on the amount of degrees that you've gone around your unit circle. Okay, and then similarly, if you want tan, it's the same as y over x, and that's where we get the whole idea that tan theta is equals to sine theta over cos theta, and that is in your formula tables on page 13 as well. So the unit circle is really useful for understanding lots of different things about our trig ratios. Another important thing you should learn off is your cast. It's called cast in your unit circle. So basically you just remember that in your unit circle you write down CAST, and it helps you to know where things are positive. So everything is positive here. That's for all. Sine is positive here, tan is positive here, and cos is positive here. So if basically you're looking at cos in here, it will be negative, or cos in here would be negative. And we can use our unit circle to help us with our sine, cosine, and tangent graphs. Now, I'm not going to have time to go into this in detail right now, but just to say that if you are interested in learning how the unit circle links with your sine, cosine, and tangent graphs, please check out the videos on our website. I go through that in lots and lots of detail. But one of the most important things you need to know when you're kind of studying your sine and cosine and tangent graphs, you obviously need to know how to graph them, and you also need to know information about their period and range. So the period of a function is basically how long does it take before the graph starts repeating itself. Okay, and it's all to do with your x coordinates. So if we imagine it here, we start here at the point 0, 0, we go up to 1, we go down, and we get to this point. And then the graph starts repeating itself again. So we can see that the period of the graph, which again is linked with your x-axis, is 2 pi because it goes from 0 to 2 pi. So every 2 pi, your graph repeats itself. So that's where the period comes from. And then the range is linked with your y-axis, and that's how high of your outputs or how high along your y-axis your graph goes between. So we can see this graph goes between -1 and 1, and that's where the range comes from. And that's the same for your cosine graph. You can see the exact same thing. It has the same period because, again, even though we start at a different point, we start at 1, we're going down, we're going back up, and then it starts again. And we have our period is 2 pi, and the range, again, is between -1 and 1. Your tangent function then is slightly different, and the reason why we have some of these asymptotes is basically when you divide by 0, you get like a math error, so that's why you've certain areas that are not defined, and the period of your tangent graph that you need to learn is pi rather than 2 pi. Okay, so the last thing we're going to talk about then in today's Saturday session on our YouTube Live is transformations of trig functions. So basically this is just a really quick recap of transformations to help you to understand, and this has come up on the Leaving Cert before, if you're given something like this and you're asked to graph it. The way it has come up in the past on the exam is where they'll give you maybe the sine graph and then they'll ask you to graph this one. So what you need to remember is, so you can see here we've got like a, which is like a number stuck in front of cos or sine, and then we have n in here, which is just a number that's in front of our angle in beside sine or cos. So the easiest thing to remember is that if it's in here, it's impacting your angle, which is to do with your x-axis, which is to do with the period of your graph. So if you remember, anyone who's looked at any of my transformations videos in the past, if it impacts something to do with the x, it's going to do the opposite to what you think. So instead of multiplying by n, we actually divide by n. So you're going to divide your period by whatever that number is. So if we look into this example on the right hand side, we can see it's 2 pi. So that means we know the period of a sine graph is normally 2 theta. The period of a sine graph is normally 2 pi. So I'm going to divide it by 2, and that gives me pi, which is the new period of this graph. And if the number is on the outside, like it is here, so we've got our a on the outside, that's going to impact the y values, and it's going to do exactly what we think. So we know the y values are linked with the range of our graph. So if there's something outside, you multiply the range by a. So in this case, there was a 4 outside, so we went from originally having -1, 1 to multiplying both those by 4, and that's where we get our -4, 4. To give you another really quick example, if we had -3 plus 5 sine 3x. So the first thing we do is we take care of the period of your graph. So we say to ourselves, okay, there's a 3 in there, which means I need to divide the period by 3. So you think the period of a sine graph is normally 2 pi, so we divide it by 3, and that's where we get your period. For the range then, we said if there's anything outside, it impacts the range or the y values. So it's going to multiply it by 5, and actually this one is just a plus or a minus, so it just subtracts 3 away. So we're going to take the range of a sine function, which is -1 and 1, and we're going to start by multiplying it by 5. So that's going to become -5 and 5, and then we're going to subtract 3 away. So we end up getting -8 and 2, and that's where your range comes from. Okay guys, so we didn't have time just at the end of today, so I'm conscious of the time, to go through our trig equations in loads of detail, but I'm just going to do one of them with you now really quickly, and there's another one at the end of this that you can also have a quick look at in your own time. So this is a quick recap of how to solve trig equations, which again is linked with the higher level Leaving Cert maths course. So the first thing that you're going to do to solve a trig equation is you're going to work out what the reference angle is, okay? So we're going to work out sine inverse of √3 over 2. So on your calculators, we're going to do sine inverse of √3 over 2. And again, please do check out our videos for this done out in a bit more detail. And we're going to use cast to help us here. So I can see that this was a positive answer. So I need to work out where sine is positive. So I know it's positive here for all, and it's positive in here. So that means this is where my reference angles would be tucked inside. But we want to work out the actual angles. So I'm going to say, okay, well, my first one is going to be 60, but my second one starts from 0 and all the way around. So it was basically 60 less than 180 degrees, which is going to be 120. So that's the first thing. So we've basically worked out that we have our first two angles are going to be 60 and 120. But we want to work out all of the angles, because remember, like your trig graphs, your trig equations, your functions, they're cyclical. They can continue to rotate, okay? So we need to represent what's in here. So we're going to say that 3x is equals to the first angle, which is 60 degrees, plus 360 degrees n. That's basically just saying that if I rotated it another 360, I'd have another angle that would satisfy this, comma, and then the other angle, which we said was 120 degrees, plus 360 n. Now, because there's a 3 in front of here, even though we were told that x is between 0 and 360, you would think that they are just our two answers. If it was just x, they would just be our two answers. But because there's a 3 there, it means that in a couple of minutes, we're going to have to divide everything by 3 to get our actual x value. So what we're going to have to do then is we're going to have to actually work out more values that will look like they're bigger than 360 degrees, but ultimately when we divide by 3, they will become less than 360. So we're going to let x equals to, n I should say. We're going to let n equals to 0, n equals to 1, and n equals to 2. Okay, so we're going to write down then the 360 is equals to, so when n is 0, it's just going to be 60 degrees and 120 degrees. But then we're going to substitute 1 in here and here. So we're going to have to do 60 plus 360, which gives me 420, and 120 plus 360, which gives me 480. And then we're going to substitute in 2 in there and in there. So that's going to be 60 plus 360 times 2, which gives me 780, and 120 plus 360 times 2, which gives me 840. And finally then, to get our x value, we're going to divide all of these by 3. So we're going to have 20 degrees, 40 degrees, 140, 160, 260, and 280. Now, if you were curious and you wanted to go and let n equals to 3, you could go and do that. But when you divide, you'll see that your answer is actually bigger than 360, which does not satisfy what we were being asked to find. So that is your answer for solving trig equations. So guys, I'm going to leave it there for today. And there's one more question at the end of this, which you can have a go at in your own time. We are going to send out these notes to anyone who has inputted their email address into the comment section below. So please do that. And again, it's just a reminder that we've got our H1 notes on trigonometry up on our website. The entire course is broken down into bite-sized videos. And one thing that I didn't have time to go through today was in relation to proving your trig formulae, okay, or deriving them and being able to prove them. So that's just something that I have done out the entire thing in videos and into notes of deriving your trig formulae, which you are expected to know for the higher level course, and that's all in there for you as well. Thank you for watching today, guys. Hopefully it was useful for you all. And if you do have any questions, feel free to send them through to us after our live and we'll get back to you on it. And if you do have any other queries about our Easter revision courses, we're happy to answer them. You can contact us through the website or through our Instagram page. Thanks a mil for watching, guys, and I will talk to you soon.